Okay, we're gonna do more u substitution, but what happens, we're going to tackle what happens when not all of your x variables cancel. So it's like we're going to do like an extra step. The other thing we need to tackle today is when I change my equation so that it's written in terms of u, we also will have to change our limits of integration. So our lower and upper bounds of integration. So this is, oh, you can't write in highlighter. Okay, the limit of integration will have to change when I change my, when you change the variable that you're taking the integral with respect to, okay? So this is all fancy talk for, we're gonna change our upper bound to u of that b value, and then we're going to use the u equation to find the lower bound, basically. Fancy talk. All right, so first example, we're going to start by using u substitution, and I would like to, looks like I want to take the derivative of x squared, so that when I, yeah, let's do that. Okay, so I have the u is equal to x squared plus 1, and du is equal to 2x plus 0 dx. All right, so dx is equal to du over 2x. Cool. All right, so I'm going to take the integral. I'm not going to write my bounds yet. I have x times u to the third power du over 2x. So I see that my x's are going to cancel, so that's good. But now what we need to do is find our new upper and lower bounds. And the reason why we take the time to do this is so that I don't, when I take a definite integral and change the upper and lower bounds, I do not have to change my my equation back to in terms of x. I can leave it in terms of u. It makes it a little bit easier in the end. So to change the upper bound, you do, or the low, let's do the lower bound first. We do u of a. So a is equal to 0, right here, our lower bound. So we do u of 0 would equal 0 squared. We use this equation right here, plus 1. So u of 0 is equal to 1. U of b is equal to u of 1. So that would be 1 squared plus 1, which is 2. Okay, so now what we're doing is we're integrating from 1 to 2 of u cubed du over 2. So 1/2 times the integral from 1 to 2 of u cubed du. Okay, all right, so we're going to take the integral, the definite integral. So I have u to the 4th. I need to multiply by 1/4 then. And we're going to integrate from 1 to 2. All right, now we just, since we changed our upper and lower bounds, we can just substitute in 2 for u. So I have 1/2 times 1/4 times 2 to the 4th power minus 1/4 times 1 to the 4th power. And that will come out to 15 over 8. That's that. So we do have to change the bounds when we change our the variable that we're taking the integral with respect to. Okay. All right, let's do number 2. So it looks like we have a definite integral, so I'm going to have to change the bounds. And I know that this is the integral from 1 to 5 of 2x minus 1 to the 1/2 power dx. So the inside looks like 2x. I know that I can take the antiderivative of u to the 1/2 power, so I want to swap out that 2x with u. So du is equal to 2 dx. dx is equal to du over 2. So we're taking the integral from 1 to 5. Oh, wait. Okay, let's try that again. We're going to change out the 2u with 2x plus 1 with a u to the 1/2 power. Our dx becomes du over 2. The divide by 2 is just a scalar, so we can just move it out to the front. But I need to change my bounds. So I have u of 1, because that's my lower bound, is, I'm using this u equation. So 2 times 1 minus 1 is equal to 1. And then u of 5, the upper bound, is 2 times 5 minus 1, which is equal to 9. So I'm integrating from 1 to 9 now. Okay, so I'm just going to rewrite this. This is 1/2 times integral from 1 to 9 of u to the 1/2 du. Okay, so 1/2 times u to the 3/2 times the reciprocal, which is 2/3, from 1 to 9. Okay, up next, we just substitute. I'm going to pull out this 2/3 to the front, so it's going to cancel. The 2's are going to cancel, and I get 1/3 times u cubed evaluated at 1 and 9. So I get 1/3 times 9 to the 3/2 minus 1 to the 3/2. Okay, the bottom number tells us we're taking the square root. So the square root of 9 is 3, and then cube that, that would be 27. So I have 27 over 3 minus the square root of 1 is 1, and cube it is 1, so minus 1/3 gives me 26 over 3. All right. All right. Now, what happens if not all of our x's cancel out? So sometimes we're left with extra variables. Oh, no, it's okay. We can deal with this. Okay, so we're going to take the derivative of the inside, which we think is 2x plus 1, right? Okay, so I get u is equal to 2x plus 1, so du is equal to 2 dx. dx is equal to du over 2. Let's replace, so we get x times u to the 1/2 power du over 2. And this time nothing cancels. So what do I do with this x? We need to replace it so that this equation is written in terms of u. So we take this u equation and we solve for x. Okay, so we subtract 1, so u minus 1 is equal to 2x. X is equal to, divide by 2, u minus 1 over 2. Okay, we're going to swap out, so we're going to swap out x with u minus 1 over 2 times u to the 1/2 power du over 2. And right away, I can see that I can take out the 1/2 and the 1/2 from my fractions and factor them out to the front. So 1/2 times 1/2 is 1/4, leaving me with u minus 1 times u to the 1/2 power du. I need to simplify this, so let's go ahead and multiply in the u to the 1/2 into the parentheses. So I get 1/4, times the integral of u to the 1 times u to the 1/2 would be u to the 3/2 minus u to the 1/2, and all of that with respect to u. All right, so we get 1/4. We're going to integrate times, all right, u to the 5/2 times the reciprocal, so 2/5, minus u to the 3/2 times the reciprocal, 2/3, plus c. All right, we're going to multiply in the 1/4 and change out the u with 2x plus 1. So I get, it looks like 2/20, which is 1/10. U is equal to 2x plus 1. I'll just write it here. So 2x plus 1 to the 5/2 minus 2/12, which is 1/6, times 2x plus 1 to the 3/2 plus c. Now, I know that the c is technically 1/4 c, but when we solve for the c value, it's just a constant. So changing it by 1/4 doesn't really matter as long as I know when I plug in my initial values that we're going to get 1/4 the value of what I would have here. That's all. Okay. And that's it. Let's do another one. So we're this time we're going to take a definite integral. Woo! And we have to change, so we're going to have to change the limits of integration. And probably we're going to have to swap out an extra variable because that's what I said we had to do. Okay, so this time I see the inside function is x squared plus 3 because it's being raised to the 5th power, so I need to replace that somehow. So let's go ahead and say u is equal to x squared plus 3. So du is equal to 2x, taking the derivative. Derivative of 3 is 0, dx. So dx is equal to du over 2x. Okay, so that's the first part. Let's go ahead and rewrite this just to make sure it works out somewhat nicely. Is equal to, no bounds yet. We'll replace those in just a second. Okay, so I have x cubed over u to the 5th power times du over 2x. And I notice that one of the x's cancels. So actually, let's do, okay. So I get, what I'm going to have to do is replace the x squared by solving for x squared in this equation. But let's go ahead and get our upper and lower bounds because it looks like this is going to work out okay. So u of 0 is equal to 0 squared plus 3. So that's 3. And my lower bound, or my upper bound, sorry, is u of 1. So u of 1 is equal to 1 squared plus 3, which is 4. Okay, so now we're going to integrate from 3 to 4 instead of 0 to 1. All right, so I have the integral from 3 to 4 of x squared over u to the 5th du over 2. So I'll bring out the 1/2 to the front. All right, last part, we need to change out the x squared. So we use our u equation. U is equal to x squared plus 3. And look, we need to isolate x squared anyway. So u minus 3 is equal to x squared. Cool. We're going to substitute that in for x squared. So I get 1/2 times the integral from 3 to 4 of u minus 3 over u to the 5th du. Now I have a monomial on the bottom and a binomial on the top of the equation, so I'm going to divide it into both terms. So I get 1/2 times the integral from 3 to 4 of u to the 1 power minus 5, which is u to the negative 4, minus 3u to the negative 5 du. Time to integrate. So I have 1/2 all times u to the negative 3 times negative 1/3 minus 3, and I usually leave a space, u to the negative 4 times negative 1/4, since I'm dividing by negative 4. Okay, all integrated or evaluated from 4 to 3. All right, so next up, we are going to just substitute in the values 4 and 3 in for u. Actually, I'm going to simplify this. Yeah, why not? I'm gonna factor in, well, that was crazy. Multiply in the 1/2. So I get negative 1/6 u to the negative 3. Actually, it's negative 1/6 u to the 3rd plus, because a negative times a negative, 3/8. And then u to the negative 4 would be u to the 4 in the denominator. Okay, we're going to evaluate from 3 to 4. Okay, so lastly, we have negative 1/6 times 1/6 times 4 to the 4. Why did I put to the 4? To the 3 plus 3/8. We're using 4 again. 4 to the 4. Yep. Okay. Minus, same thing but with a 3. So negative 1/6 of 3 to the 3 plus 3/8 times 3 to the 4. All right, we got this. All right, I have negative 1/384 plus 3/2048. Okay, a minus times a minus is a plus, 1/162. And then a minus times a plus is a negative, so 3/648. All said and done, my calculator told me this is 1.3449 times 10 to the negative 4, so move the decimal 0.000134. That's not a lot of area under the curve, is it? A little bit of area. Okay, that is that.